Structural engineering is a core branch of civil engineering, in which structural engineers are trained, understand, evaluate, and calculate the stability, strength and rigidity of built structures, for buildings and non-building structures in order to make structure impregnable. It is the responsibility of the structural engineer to develop designs, and integrate their design with that of other designers, and to supervise construction of projects on site. They can also be involved in the design of machinery, medical equipment, and vehicles where structural integrity affects functioning and safety. The recorded history of structural engineering starts with the ancient Egyptians. In the 27th century BC, Imhotep was the first structural engineer known by name and constructed the first known step pyramid in Egypt. In the 26th century BC, the Great Pyramid of Giza was constructed in Egypt. It remained the largest man-made structure for millennia and was considered an unsurpassed feat in architecture until the 19th century. Throughout ancient and medieval history there is no such record exists of the first calculations of the strength of structural members or the behavior of structural material. Most of the architectural design and construction was carried out by artisans, such as stonemasons and carpenters, rising to the role of master builder. Structural engineers are responsible for engineering design and analysis. Entry-level structural engineers may design the individual elements of a structure, and that is the beams, columns, and floors of a building. More experienced engineers may be responsible for the structural design and integrity of an entire system, such as a building. Structural engineers often specialize in particular fields, such as bridge engineering, building engineering, pipeline engineering, industrial structures, or special mechanical structures such as vehicles, ships or aircraft. Most structural engineering jobs require at least a bachelor's degree in engineering. Many employers, particularly those that offer engineering consulting services, also require certification as a professional engineer. A master's degree is often required for promotion to management, and ongoing education and training are needed to keep up with advances in technology, materials, and computer hardware and software and government regulations. The role of the structural engineer is a key component in the construction process. Structural engineers will need to possess excellent numeracy and analytical skills. He should familiar with computers and software programs. He must have ability to work well as part of a team. Also use own initiative and to pay close attention to detail. He should have ability to explain complex conceptual information in simple terms and ability to work to tight deadlines and remain calm under pressure. He must have ability to stick to tight budgets and willingness to take responsibility for major decisions. Most structural engineers use 3D integrated structural analysis and design software in their daily work. This software makes modeling geometries of structures and analyzing loads much more efficient, therefore decreasing the time and effort needed for finite element analysis. These are the three most used structural design and analysis software. SAP 2000. SAP 2000 is used in more than 160 countries worldwide. From transportation facilities to public works, it is widely used due to its effectiveness and 3D object-based modeling features. The new SAP 2000 version 18 can now generate stability checks for nonlinear load cases, as well as exporting its models into Revit structure. STAAD.Pro. STAAD.Pro is used for both linear static and nonlinear analysis. STAAD.Pro is adept to analyzing time-dependent effects, such as creep, shrinkage, and cracking of concrete. STAAD.Pro developed successfully by the software company Bentley. Bentley has also boasted that their programs can design structures using over 80 international codes and can generate structural design documents automatically. RISA 3D. RISA 3D is another 3D analysis and design software for general structures, such as buildings, crane rails, arenas, industrial structures, bridges, etc. For specific use, RISA 3D can be integrated with other RISA products, such as RISAFloor, RISA Connection and RISA Foundation. Structural engineers have a wide range of responsibilities, not least a duty to ensure the safety and durability of the project on which they are working. The important consideration of any structure is to its integrity and the ability of a structure to withstand its intended loading without failing due to fracture, deformation, or fatigue. Construct the elements with structural integrity to prevent catastrophic failure, or else it can result in injuries, severe damage, death, and monetary losses. Structural engineers on a regular basis will perform the following tasks: performing accurate calculations of pressures and stresses placed on each element of a building, analyzing blueprints, maps, reports, and topographical and geological data, using computer software to design models of structures, deciding which materials would be most suitable for each part of the structure, assessing the budget of each project, estimating the cost and quantities of materials, equipment and labor, performing thorough examinations of pre-existing buildings, recommending complete or partial rebuilding or repairs, meeting regularly with architects and engineers involved in each project, inspecting project sites to monitor progress and ensure the project is being constructed according to design specifications. The major employers of structural engineers include local authorities, oil companies, railway operators, civil engineering contractors, public utility companies, the civil service. According to the report based on the responses of PayScale Salary Survey, median pay for entry-level structural engineers is around $60,000 per year. Cash earnings of entry-level structural engineers can occasionally include $6,000 each in bonuses and profit-sharing proceeds. This strong performance component causes pay grades to stretch from approximately $49,000 to almost $76,000. The U.S. Bureau of Labor Statistics states that employment of civil engineers is projected to grow 8% from 2014 to 2024, about as fast as the average for all occupations. Having good grades from a highly rated institution should give a job seeker an advantage over the competition. As infrastructure continues to age, civil engineers will be needed to manage projects to rebuild bridges, repair roads, and upgrade levees and dams, as well as airports and building structures of all types.